So students, in the last lecture, we have started the chapter on multiple integrals. In this chapter, we have seen about double integrals. And we have seen the concept of double integral, how to solve given example with double integration. That means we are solving the integrations one by one. First we solve the inner integral, then we are solving the outer integral. But I told you that you must keep in mind that the inner integral is with respect to which variable, either with respect to x or with respect to y. So if dx dy is written, then at the first look we can observe that the first integration may be with respect to x, but we should also focus on the limits of inner integral. So if it is y equal to fx form, then the integration is with respect to x. If it is into x equal to f of y form, then the integration is with respect to y. So those examples we have seen are with respect to with the given limits of integration. That means the limits of integration, that means lower limit and upper limits were already given to us. And also I told you that the limits of outer integral are always constants. I am repeating this sentence always because some students are making mistake that they write the limits of outer integral in variable form. These are never in variable form. And this point must be clear to you, and you must keep in mind, because this will be useful in the examples which we will consider in today's lecture. Okay? So here we want to see the double integrals where the integration is of the form, suppose f of x y dx dy, and now and onwards we will write this as dA. Okay, and here we will write down r. That means we can see that the limits of integrations are not given. So our main target is to determine the limits of these two integrals, inner integral and outer integral. Okay, if limits are given, then we can continue to integrate it directly. But if limits are not given, then first we require to determine the limits, and this is the main task of this double integral. Okay, once if you are clear with this task, and if you are already aware with how to determine the limits, then there is no problem, because after determining the limits we come to the original solution steps. That means we need to integrate simply as we integrated the problems in the last lecture. Okay, so here first of all we will make note what is dA. dA here is either dx dy or dy dx, whatever it is, the order I told you that, because here the limits of integration we want to determine, and this depends upon us whether we want to integrate it first with respect to x or first with respect to y. Suppose if we want to integrate first with respect to x, then we will write dA equal to dx dy, and if we want to integrate first with respect to y, then we will write dy dx. That means in this case the limits of this integration should be x equal to f1y to f1 x equal to f1y to x equal to f2y. That means this is the lower limit we write over here, and this is the upper limit we write over here. And the limits of this integration are of y, and these are constants. Y equal to c2, y equal to d, obviously. Okay. So now the main task is that how to determine the limits. So to determine the limits, we will focus on this r. R is nothing but the region. R is nothing but the region. So the region of integration is very much important. And to determine the limits, we will have to draw the figure first in xy plane. Okay. So the region can be drawn by using the given equations of different kinds of curves. Okay, suppose one curve is given like this, This is suppose y equal to gx. Suppose we are given one another curve, we say x equal to a line, x equal to b line, and also x-axis. X-axis has the equation y equal to 0. You must be knowing. So the region must be bounded. So one boundary is this one, second boundary is this one, third boundary is this one, fourth boundary is this one. So the region we are considering is this part. Okay, and after determining the region R, this is the region R. Okay, after determining the region R, we need to determine the limits of x and y. So if we want to integrate first with respect to x, then we will write down first x here and then y here. Obviously the limits of y will be constants. Okay, these may be constants or some functions. But this will be appear in the form of x equal to f1y and x equal to f2y. f1y less than or equal to f2y. And this is less than or equal to c to d. In this way we determine. So to determine the limits of x first, that means if we want to integrate in this way, then in this region R, we need to consider one strip line parallel to x-axis. See, we need to consider a strip line parallel to x-axis because we want to integrate first with respect to x. Are you clear with this? Okay. So if we consider the strip line parallel to x-axis, then we have to focus on the two endpoints of this strip line. Actually, strip line can be drawn in this way. This is the strip line drawn, but no need to make decorative form. Only single line if we draw. And in this region, we can draw this line anywhere. If you want to draw here or here or here, anywhere. Okay. But mostly we will draw the line in between, so as loop-wise we can. It will be good, and we can determine the limits in an easy form. So to determine the limits of x, first we should focus on these two endpoints. Okay, then we will have to move the strip line from this x-axis towards curve, and then we can determine the limits appropriately. To understand the concept clearly, let us focus on one example. It will be clear to you from the example. So we will see one example here. Suppose we are given the example, evaluate double integration e raised to 2x plus 3y dA over the region R. Here dA means dx dy or dy dx, and this depend upon us. That means with respect to which variable we want to integrate first, where R is the triangle, bounded by x equal to 0, y equal to 0, and x plus y equal to 1. Okay, so now see in the solution part, and see here in the example we want to evaluate this double integration where limits of integrations are not given. As I told you, if the limits are given, then we can proceed directly to integrate, but here limits are not given. So first of all we require to determine the limits of integration. Okay, and to determine the limits of integration we need to draw a figure, because without drawing the figure we cannot determine the limits. You must be clear with this fact that the figure is very much important to determine the limits. Okay, so on the right hand side part or in between we will draw the figure first. X-axis, it is y-axis, and here no need to take the measurements of so that means no need the scaling. We can draw it approximately, but we should know the type of the curve, which kind of curve is this. So here it is bounded by, that means the region R must be bounded by the given boundaries. If the boundaries are not given, then we cannot consider the involved region, bounded part. Okay. So here x equal to 0 is given. X equal to 0 is nothing but y-axis. You must be knowing, because this is the origin. So x equal to 0 means y can be assumed any value. So this is y-axis. Y equal to 0 means x-axis, because here y equal to 0 and we can assume any value of x. So this is x-axis. So these two are the boundaries, x-axis and y-axis. One more boundary is x plus y equal to 1. X plus y equal to 1 is the equation of straight line. You must be knowing. Equation of the straight line is in the form of ax plus by equal to c. Ax plus by equal to c. So to draw the straight line, we require 2 points, at least 2 points, and if 2 points are there, then we can join these 2 points by means of a line, and the 2 points we can determine very easily. If we put y equal to 0 here, then we get x equal to 1. So suppose this is 1 comma 0 point. So this is the 1 point. So the line will pass through this point. If we put x equal to 0, then y equal to 1. That means it is the point, say 0 comma 1. Okay. So we can see that the straight line will pass through this point. And here we will write down the equation x plus y equal to 1. This is the straight line. So now we will find out the bounded region. Actually, when you will try to solve the example yourself, then you can do it very fast. Here we are going slowly because I want to explain to you and explain to you that how the region can be determined. So you can see that this is the boundary, this is the boundary, this is the boundary. So the region bounded by, so you just put dots over here, dots within the region. So you can see, observe that this is the required region within which we want to find out the limits. So now region is obtained. Now we want to integrate this one, and as I told you that we require to determine with respect to which variable we want to integrate first, either with respect to x or with respect to y. So if we want to integrate with respect to x first, then take a strip line parallel to x-axis. That means take a strip line parallel to x-axis. Okay, because we want to integrate it with respect to x first. So here in the region anywhere I will draw the strip line parallel to x-axis. You can see. Okay. Therefore, the limits are. What will happen? First we will determine the limits of x and then the limits of y. So we will write down the pattern in this way. Okay. Now, first focus on the two endpoints. See, two endpoints of the region of the straight line, and then see left endpoint and right endpoint. Left endpoint we will put over here, and right endpoint we will put over here. So see, the left endpoint, focus on that the left endpoint lies on which curve. Where is it? This is no question, because I told you that I can draw straight line anywhere in the region parallel to x-axis. So where the point is, this is no important, but on which curve it is, that is important. So we can see that this point is on y-axis. On y-axis. And y-axis has the equation x equal to 0. So x equal to 0. We will write down. Then see right hand point. Here again, this end point, right hand point, Where is it? It is no problem. But on which curve this right hand point lies? This is important. And we can see that this right hand point lies on this straight line. And this straight line has the equation x plus y equal to 1. So from this we will formalize that x equal to 1 minus y. So we can see that x lies between 0 and 1 minus y. Here 1 minus y is there because this length of this line is varying. So it depends upon y. It depends upon y. And this point is fixed. Okay. Then we will determine the limits of y. And I told you that you must keep in mind that the limits of y will always be constant. Always it will be constant. So by mistake you should not write the limits of y in terms of x. In terms of x, that is in variable form. To do this, see here the strip line actually in this region. In this region, focus on y-axis. Focus on y-axis. So the region starts from which point? Here the region starts from this point and ending at this point. So here y equal to 0 you can see. Y equal to 0 and it is here. Focus on y-axis. So here y is what? At this end point you can see y equal to 1. Y equal to 1. Okay. So you can see the limits have been determined. Therefore, now we can put the limits of integration 0 to 1 and 0 to 1 minus y e raised to 2x plus 3y dx dy we will write because our first integration is with respect to x. And then our procedure is same as we discussed in the last lecture. That means the integration of this is 0 to 1. Here we will integrate this with respect to x, and I told you that when we integrate with respect to x, y is considered as constant. This 3y is constant. So integration of e raised to 2x plus 3y is nothing but divided by 2 because 2x plus 3y has the derivative. 2x has the derivative 2 and 3y has the derivative 0 because it is considered as constant. 0 to 1 minus y, and now we will write over here dy only. Okay. So we will integrate this one 0 to 1. 1 half I will take outside, this 1 half I will take outside, because if we will keep it inside then we will get confused. That means every time we require to write down divided by 2 etc. So here to avoid this I have avoided. So 1 minus y we will put. What is which value of this one? 1 minus y is the value of x. So here we put x equal to 1 minus y. X equal to 1 minus y, that means what will happen? 2 minus 2y plus 3y. 2 minus 2y plus 3y, that means 2 plus y. Okay? Then here is minus, we will put x equal to 0. If we put x equal to 0, it is nothing but e raised to 3y dy. Okay? Then we will integrate it with respect to y. So here the integration of e raised to 2 plus y is e raised to 2y itself, because 2 has the derivative 0 and y has the derivative 1. So 1. And if you don't write here 1, then also it will do. Okay? And e raised to 3y has the derivative e raised to 3y divided by 3. Okay? So the limits are from 0 to 1. So 1 half, we put y equal to 1. These are the values of y. Y equal to 1, so it is e raised to 3. Minus, here if we put y equal to 1, it is e raised to 3 divided by 3. Then we will put 0, lower limit. Then 1 minus sign will come. Y is 0, so e raised to 2. Okay? And one more minus sign here will come, so it will become plus. E raised to 0 is 1. So 1 by 3. Okay? And then we can combine it to get e cube by 1 minus e cube by 3, that is 3 minus 2 e cube by 3 minus e square plus 1 by 3. So this is the required answer. So integration, process of integration is very simple, but main task is to determine the limits of integration. So all of you write down this solution. Okay. So now, see, the same problem we will see in different way. That means I told you that the limit determination of limit depends upon us whether we want to integrate first with respect to x or y. And in this solution, I have shown to you that we wanted first integration with respect to x, and therefore that's why we determined first the limits of x, then the limits of y. But now suppose the same problem I will solve in another way. Suppose I want to integrate first with respect to y. So if you want to integrate first with respect to y, then take a straight line parallel to y-axis. See, in this way. So here write down, take a straight line parallel to y-axis. Therefore the limits are, first we will determine the limits of x, then the limits of y. Okay? Okay. Now, the same kind of approach we will follow over here. We want to integrate first with respect to y. So here we will write down dy dx. So to determine the limits of y, we have taken straight line parallel to y-axis, and then focus on the two endpoints of this straight line. Okay, only on the endpoints, not on the line. So see the lower endpoint we will write over here, and the upper endpoint we will write on right hand side. So see the lower endpoint. As I told you in the first case, where the point is, this is not important, but this endpoint lies on which curve, it is important. We can see that this endpoint lies on x-axis. On x-axis we have y equal to 0. So write down 0 here. Then focus on upper endpoint. Upper endpoint lies on which curve? It is on this straight line, and this straight line is the equation x plus y equal to 1. So if we formalize this, then y equal to 1 minus x. Y equal to 1 minus x. So these are the limits of y. Now we will determine the limits of x. So the limits of outer integral are always constants. Always constants, that means they are in some value. Okay? To do this, to determine the limits of x in constant values, focus on x-axis. On x-axis, the region starts from this point and ends at this point. So here what is x? Here what is x? X equal to 0, you can see. And see here at this end point, because the region is finishing over here at this point. Okay? So starting of the region on x-axis at this point and ending at this point. And at this point x equal to 1. So this is the limit. We will put the limit 0 to 1 minus x and 0 to 1. Then we will integrate. Here you see, in both the cases, in first case, in the second case, we will get the same answer. We will get the same answer. Answer will not change. So here, this can be integrated as 0 to 1. If we integrate this with respect to y, here x is remain as constant. So 2x plus 3y divided by 3, because we are integrating with respect to y. X has directly 0. 0 to 1 minus x dx. And this is equal to 0 to 1. 1 by 3 we take outside. So here it is e raised to 2x, y equal to 1 minus x. See, it is y equal to 1 minus x. So 3 minus 3x. 3 minus 3x plus 2x. That means 3 minus x minus y equal to 0. See, this is the value of y. So y equal to 0. So it is e raised to 2x dx. Then we will integrate this one. 1 by 3. If we integrate this one, then e raised to 3 minus x has the integration 3 minus x divided by minus 1 because minus x is here. 3 has derivative 0, minus x has derivative minus 1. This is minus e raised to 2x by 2. And the limits are 0 to 1. Okay? So we will put the values over here. This is what? Minus 1 is here. So minus I will write over here. X equal to 1 if we put, it is e square. It is e square. Minus, here if we put x equal to 1, it is e square by 2. E square by 2. Then we will put 0. Then 1 minus sign will come. Here 1 more minus sign is there. So it will become plus. So e cube. And here if we put 0, then it will become plus. E raised to 0 is 1. So 1 half. Okay. So you can see that it is 1 by 3 minus e square minus e square by 2 is what? Minus 1 minus 1 by 2 means minus 3 by 2 e square e cube plus e cube plus 1 half. So if I will divide this by 3, then we will get minus 1 half e square plus 1 by 3 e cube plus 1 by 6. Same here we have obtained the answer as C e cube. It was e cube by 3 1 half minus e square by 2 plus 1 by 6. See, you can see both the answers are same. So main target here is to determine the limits, and it depends upon us whether we want to integrate parts with respect to x or y. And you can do in any way, but only one way is appropriate. No need to solve it by using both the cases. You can solve by using any one case. But before of that, you must focus on this function also. If it is integrated first with respect to x easily, then integrate it with respect to x first. If it is integrated first with respect to y easily, then integrate it first with respect to y. Okay? In our example, it was simple in both the cases. It was simple in both the cases. Okay? So you write down this. Let us see one more example. Evaluate double integration over r xy dA, where r is the region bounded by, where r is the region bounded by x-axis, ordinate x equal to 2a, and the curve x square equal to 4ay. Okay, so here again you can see that the limits of integration are not given, so our target is to determine the limits first. But here you note that if the integration is given, suppose 0 to x and xy dx dy or dy dx suppose. So you cannot write this in the way, you cannot change these limits 0 to 1 xy dx dy. You cannot do. This is absurd. It is wrong, totally wrong. You cannot reverse the changes. That means this limit you write down over here and this limit over here and change the role of dy and dx. No, you cannot do. You will have to, if you want to change the limits, you must need to draw a figure. And this will also come in the remaining coming lectures. Okay. So here we will solve this example. First we will draw a figure, x-axis, y-axis. So here it is given the first boundary as x-axis itself. So this is the one boundary. And x-axis we know that it is given by y equal to 0. Only that x equal to 2a. X equal to 2a means suppose this is a and this is 2a. So x equal to 2a, suppose this is 2a. So x equal to 2a passes through this point. You must be knowing. So this is nothing but the equation of straight line. Equation of straight line, it is x equal to 2a. If x equal to 1, also we can draw line. X equal to 2, we can draw line. If y equal to 1, we can draw line in this way. Y equal to 2, we can draw line in this way. So here, x equal to a is here. Approximately we can take. Not require exact scaling. Okay. Then the curve x square equal to 4ay. X square equal to 4ay is nothing but the equation of a parabola. This is nothing but the equation of a parabola. Okay. Parabola, and it is given in the form of y equal to x square. Y equal to x square, that means x square, y is written in terms of x square, that means x can be considered negative or positive. X can be considered as negative or positive, but y is always positive. Y is always positive. So the curve will go in the positive direction of y. And you know the nature curve, type of the curve, parabola, which can be drawn in this way. Okay. So it is nothing but x square equal to 4ay. It proceeds towards y-axis. So now see, we will find out the region. Which is the region? This is the boundary given. This is also given. This is also given. So the region is this one. Okay. So now our region is identified. But before of that, just we will also find out this point, intersected point. This point is nothing but the intersection of these two curves. X square equal to 4ay and x equal to 2a. So if we put here x equal to 2a, x equal to 2a in this equation, 2a that means 4a square equal to 4ay. So 4 will be cancelled, a will be cancelled. So y equal to a and y equal to a and x equal to 2a. So this point is nothing but 2a comma a, because normally we write down the point in the form of x comma y. So x is written first, then it is written as y. Okay. So now, take now to determine the limits. Here first we focus on with respect to which variable it is easy to integrate. X into y is given. So in both way it is easy with respect to x or with respect to y. So best way is to take straight line parallel to x-axis. So take a straight line parallel to x-axis. Okay. Therefore, the limits are first x and then y. Okay. See, focus on the two endpoints of this straight line. This endpoint lies on which curve? This is important. This is on parabola. X square equal to 4ay. So x equal to 2 root ay. See, x equal to 2 root ay. X square equal to 4ay. So actually we can write this as x equal to 2 root plus or minus 2 root ay. X equal to plus or minus, but we have considered plus sign because this the boundary, the region, in the region this curve is along x positive. X positive. That's why we have considered 2 root ay. Okay. And the right hand point is on which curve? It is on this line, and where it is x equal to 2a. Then we will determine the limits of y. These limits are always constants, as I told you. So focus on y-axis. So the region starts from this point and it ends at this point. Okay? The region completely lies on y-axis between these 2 points. So here y equal to 0 and here y. What is y? Y is 2a here. You can see y equal to a. Y equal to a. Okay. Therefore, our integration now will become 0 to a 2 root ay to 2a xy dA. dA means now we have dx dy. So now the integration 0 to a x is y is constant, so y we take outside. X as the integration x square by 2 root ay to 2a dy. So this is nothing but 0 to a y. This 1/2 I will take outside, so we cannot get confused. But be sure that this 1/2 is taken outside, so you don't write these two again. So we put x equal to 2a. X equal to 2a, so 2a square means 4a square. Then minus, we will write down x square. X equal to 2 root ay. So 2 is 4 and root ay means 4ay. And here it is dy. Okay. So the integration is now 1/2. See, 0 to a. This is 4a square y minus 4ay square dy. Then the integration is very easy. Integration is very easy. So you can see that this integration is nothing but 1/2 4a square. This is y square by 2 minus 4a. This is y cube by 3. And the limits are from 0 to a. 0 to a. Therefore, if we put here this y as the integration y square by 2 and this y square is y cube by 3. So now we will put y equal to a, upper limit. So this is a square by 2 minus 4a, this is a cube by 3. Okay. Then we will put lower limit 0. But if we will put lower limit 0, then this is y 0. So 0. Here again y is 0. So it is 0. So this is nothing but 1/2. This is 4 by 2 means 2. 2a raised to 4 minus this is 4 by 2 a raised to 4. Okay. So what 4 by 3. 4 by 3. So this is what 3 to the 6 a raised to 4 minus 4 a raised to 4. So 6 a raised to 4 means 2 a raised to 4 divided by 3. So this is nothing but a raised to 4 by 3. So this is your answer. You can see a raised to 4 by 4. So here you can see that we can solve the example in this way. And if you want to get practice, one more practice, then you can also try it by taking a straight line parallel to y-axis. That means first with respect to y and then with respect to x. You can try during the remaining time of this lecture. You can try to solve this by using this. So you can get practice, more practice. In the next lecture, we will see more examples based on this. Okay? Till then you can practice the examples which I have shown to you over here. Thank you.